we're going to do question 7. We are given, so it's 7.1. Selby decided today that he will save 15,000 per quarter over the next 4 years, and he will make the first deposit into a savings account in 3 months time, right? And he will make his last deposit at the end of the 4 years from now. 7.1.1, how much will Selby have at the end of the 4 years if interest is earned at 8.8% per annum compounded monthly? So this is an investment, right? So whenever it is an investment, we are going to, and the payment is made quarterly, right? So we're just going to use the future value annuity to calculate the amount of money that will be in the account in the future, right? In a period of 4 years. So we're just going to use the future value annuity, which is f is equals to x into 1 plus I to the power of n minus 1 divided by I, of which our our x, the investment is 15,000 rand, and our I, we are given is it 8.8? Yes, 8.8% per annum compounded quarterly, right? And n is equals to 4 years. So this is just the years, but we know that it doesn't necessarily mean years, so we have to multiply by the 12, by the quarter, right, in the equation. So number of payments, n number of payments. So we're gonna have f of v is equals to the 15,000 that is invested, 1 plus, we're going to change this into decimal form, so it's 8.8% divided by 100. You're going to get 0.088 divided by 4 because it's compounded quarterly, right? And to the power of 4 multiplied by 4 because it's 4 years, minus 1 into 0.088 over 4. So the future value of this investment excuse me, the future value of this investment would give you 283,972.28. so this is the future value of the investment. So now 7.1.2, if Selby decides to withdraw 100,000 rand from the account at the end of 3 years, how much will he have in the account at the end of 4 years? So this is what's happening. We're having a situation where let me draw the timeline because this is very important. My line is just not the one. So this would be your timeline of Selby's investment, where this is T0 and this is T4, right? So investments of 15,000 rands are made T1, so they're made quarterly, right? So I'm not going to write the quarters, but what's mostly critical for me is that he withdraws, so it's minus 100,000 rand at T3, right? So he withdraws that amount. So we want to know how much we're going to have the future value annuity here at T4, right? So what you can do, let me just say the amount, right? Instead of just writing the future value annuity, you can just say the amount, because this is wrong. Just say the amount. What would be the amount at T4, the accumulated amount, right? So what you can do, because he invests 15,000 rand quarterly, let's find FV from T0 to T3, right? For the first 3 years, we want to identify the future value annuity. In 3 years, we want to find the future value annuity, which is equals to x into 1 plus I to the power of n minus 1 divided by I, right? So the investment is 15,000 rand into 1 plus 0.088 over 4, because it's quarterly, so it's 4 times 3 years, right? It's 3 minus 1 over 0.088 over 4. So you can punch this and then continue from what I'm about to do, or you can just subtract, because remember, this would be the future value in 3 years, and then what happens in 3 years? There's a withdrawal of 100,000 rand, right? So it's either you can punch the entire thing or you can punch the first part. It's up to you. I punched the entire thing. It was possible to do that in my calculator. So okay, this is 0. So yeah, punch this and find the future value in that 3 years now. So FV is going to be 100,000, 3,459.12, right? So this is the future value at 3 years, right? We want the amount in 4 years, so we still have to write down the question. So at 4 years, this is what happens. So what's going to happen is this. Now we want to identify what's going to be in the account in 4 years, excuse me, after the withdrawal was made, right? So this future value annuity is going to gain, it's going to have experienced some growth, right, from 3 years to 4 years, so which is basically 1 year, because if you write the timeline, it's T0 and then T3 and then T4, right? So now it's the difference between T3 and T4 is just 1 year, right? So we're focusing from T3 to T4, right? Which is basically, we are here, we want to identify A, right? So A would be equals to P into 1 plus I to the power of n. So we're going to add this with the future value. Remember that from T3 to T4, investments of 15,000 rand quarterly are still being made. Hence, I'm going to use the future value annuity to still calculate those investments, right? It's going to be A is equals to this future value annuity, which is going to gain some interest or whatever it is. So it's going to be 103,459.12 into 1 plus 0.088, right? Quarterly, so it's to the power of 4 multiplied by, so let me just say multiplied by 1, because it's 1 year, right? From 3 to 4 years, it's just going to be 1. And we add with the future value annuity of 15,000 rand into 1 plus 0.088 divided by 4 to the power of 4 times 1, right? Because it's 1 year minus 1. So let me just do this. So it's minus 1. Let me write this properly. So it's going to be minus 1, close the bracket, divide by 0.088 over 4. So the amount now, you can punch the entire thing in the calculator if it's possible, or you can punch this first section here and then add it with this section here, right? And then find your amount, right? So the amount that I got is 174,877.60. So that is the amount that would be accumulated in 4 years after the withdrawal was made. Now let's just do another question. 7.2. Tepo takes out a home loan over 20 years to buy a house that cost 1 1,500,000, right? 7.2.1, calculate the monthly installments if the interest is charged at 10.5% compounded monthly. So let's calculate. We're talking of a loan here, so definitely going to use PV is equals to x into 1 minus into 1 plus I to the power of minus n divided by I. So the loan that was taken by Tsepo is 1,500,000, right? And the interest rate for this is 10.5% compounded monthly for a period of 20 years, right? So it's just going to be 20 years. So you're going to multiply it with this in the formula. So we want to identify X, the monthly investment, or monthly payments rather, not investments, sorry, the repayments of the loan. So we're just gonna say substitute from this formula here. We have 1,500,000 is equals to x into 1 minus into 1 plus. We're going to divide this 10.5 by 100, right? You will have 0.105 over 12 because it's compounded monthly minus 12 times 20 years divided by 0.105 over 12. So we want x. What we will do is cross multiply here. So you're gonna have 150,000 times 0.105 over 12. Okay, let me not put this. Is equals to x into 1 minus into 1 plus 0.105 over 12 to the power of minus 1 2 times 20, and then we divide both sides by this huge expression of 0.105 over 12 to the power of minus 12 times 20, and 1 minus into 1 plus 0.105 over 12 to the power of minus 12 times 20, right? So x is equals to 150,000 times 0.105 over 12 divided by 1 minus into 1 plus 0.105 over 12. So I'm not punching into the calculator as yet until I get this final expression, because I don't want to be getting different answers, you know, towards the person who's going to mark, you know. So you always need to make sure that you round off towards the end. So x, then now you're going to find the answer to the entire expression here. It'll fit in your calculator. So the monthly investment made for this is going to be 14975.70. So this are not investments. Why am I saying that? Monthly payments for this loan, right? It's going to be 14,975.70. So now we're going to do 7.2.2. So this one here, calculate the outstanding balance immediately after the 144th payment was made. So to find the balance outstanding, we're going to equate to the p into 1 plus I to the power of n, and then you minus the future value annuity, right? Future value annuity. So what's going to happen is this. The balance would be equals to, so we're just going to multiply the loan with this here. So the interest rate is 0.105 divided by 12 compounded monthly, and then we were told that the payments are 144, right? So then we're just gonna subtract. We know the future value annuity is given as x into 1 plus I to the power of n minus 1 divided by I, right? So, and we know that the repayments would be 14,975.7 into 1 plus 0.105 over 12 to the power of 144 payments minus 1. So this is just 1 here, minus 1 into divided by 0.105 over 12. So the balance outstanding. So now you're just gonna find the answer to this, subtract it to this one here, right, to find the balance outstanding. So the balance that I found by doing that was 969,927.74. Let me know what you're finding in the comments if it's similar to this. But yes, that is the balance outstanding for this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.